Dear students, in this session, I will introduce the nature and scope of statistics and how it is used in our day-to-day life for making inferences about various characteristics of population and related issues. And remember that statistics is used in all branches of sciences. The data supplied by statistics is important for decision making. You cannot make an informed decision without correct and accurate data. It is important for the government, for the businessman, for anyone engaged in different activities. So it is extensively used in social sciences, in economics, in commerce, extensively used in natural sciences, medical sciences, psychology, political science, everywhere. So the purpose of this class and the subsequent classes, that is this program, is to introduce the basic principles of statistics and some of the most commonly used procedures in statistics. So let us start with a definition of statistics. Statistics is derived from the Italian word stato and statista. Stato and statista. Stato means state. Statista means a person involved with the affairs of the state. So statistics originally meant the collection of data, facts, useful to the state or useful to the statista, that is useful to the person involved with the state. And statistics in this sense was used in the 16th century Italy, and it spread to other countries like France, Holland, Germany, etc. So originally statistics was concerned with the collection of facts relevant for the state, that is for the statista, someone who is concerned with the affairs of the state. But today, statistics is not restricted to information useful to the state, but extends to every realm of human endeavor. Today, statistics is used not only to the spheres, activities of the state, it is used in all realms of human life. Also, in statistics, we are not restricted to collection of numerical information called data. We are not restricted to collection of data only. We collect data, summarize it, we display it in meaningful ways and analyze it. So today, collection of data is not the only area of statistics. It will be summarized, displayed in meaningful ways and analyzed. And statistical analysis often involve an attempt to generalize from the data. So statistics or statistician collect data, summarize it, analyze it, and make generalizations from the data. So statistics is a science. It is a science of information. It is a science of information, and this information may be quantitative or qualitative. Information may be quantitative or qualitative. A quantitative variable is described by a number for which arithmetic operations such as addition, division, multiplication, averaging, everything is possible. A qualitative, also known as categorical variable, simply records a quality. Simply records a quality. As an example, you consider the realty sector, where houses are bought and sold. In this context, the quantitative variable is the square feet of the house and also the number of rooms. Qualitative variables are, say, the direction of the facing, the location, whether it is urban, semi-urban, rural, etc. So, data are quantitative and qualitative. Quantitative means we describe the data by number, where arithmetic operations such as averaging make sense. Qualitative means we simply record the quality, but we can give numbers to it, but the numbers are not meaningful. So the point is, statistics is the science of decision making. A statistician collects, summarizes, records, analyzes data, and from the data, the statistician will make generalizations. These generalizations are important for decision making in business, in economics, in all the natural sciences, government, international organizations, etc., etc. So we collect data, we organize data, and using this data, important decisions are taken. Now, in statistics, or the field of statistics deals with measurements. And some variables are quantitative, some variables are qualitative. So the measurements are the actual numerical values of a variable. We have to measure a variable, the numerical values of the variable, and there are 4 generally accepted scales of measurement from the weakest to the strongest. These scales are the nominal scale, the weakest nominal scale. In the nominal scale measurements, numbers are used simply as labels for groups or classes. For example, if the data consists of blue, green and red items, we can give numbers 1, 2, 3 for these items. And these numbers stands for category only for category, and nominal stands for the name of the category. Say 1 for blue, 2 for green, 3 for red, etc. And nominal scale variables are used for qualitative rather than quantitative data. And its features are: objects are assigned to mutually exclusive categories. There are no relationship between these categories. No ordering is implied. Only arithmetic operation on qualitative nominal scale variable is you can count the number of, say, green items, blue items, red items, etc. You can count the number. No other arithmetical operation is possible. Such variables are nominal scale variables. And remember this, nominal scale variables are used to represent qualitative variables like color, beauty, gender, geographical location, etc. etc. The second one is ordinal scale. Ordinal scale. In the ordinal scale data are ordered according to the size or quality. And as an example to this, ranking of items by a consumer. So in a scale 1, 2, 3, 4, etc. 1 the worst, 4 the best. When you go to the website searching for a book, you will see that the scaling is from 1 to 5, the best, worst, etc. Consumers will give their preferences. What we know in this case is 4 is better than 3, but the size relation or the distance, how much better is not known. It is ordinal scale, ordered. The third one is interval scale. The third category is interval scale. In the interval scale measurements, value of 0 is assigned arbitrarily, so we cannot take a ratio of 2 measurements, but we can take the ratio of 2 intervals. We cannot take a ratio of 2 measurements, but we can take a ratio of 2 intervals. As an example, 0 degree Fahrenheit does not mean 0 heat. 0 heat. 100 degree Fahrenheit, not twice hot as 50 degree Fahrenheit. 100 degree, 0 degree does not mean no heat. 100 degree is not twice as 50 because 0 is given arbitrarily. As another example, 10 a.m. is not as twice as 5 a.m. 5 a.m. But we can say that the interval between 0 a.m. and 10 a.m. is, the duration is 10 hours, and it is twice as between 0 a.m. and 5 a.m. The duration is 5. So interval means, interval scale variable is one in which 0 is assigned arbitrarily so that the distances are not meaningful, as it is clear from these examples. And the last one is ratio scale variables. Ratio scale variables are nothing but quantitative variables where 0 means absolute 0. 0 is not arbitrary, 0 means absolute 0. For example, $100 is twice as much as $50. As an example, $100 is twice as much as $50. And $0 is absolute 0, no money at all. So we divide variables into nominal, ordinal, interval and ratio. Nominal is qualitative, ratio scale is quantitative. Remember this, in statistics, you have to measure variables. Variables are used in statistics to represent height, weight. All these are variables, so you have to measure it. How you measure? The question is how to measure this. It depends on what kind of variables you are using. The measurement depends on, or the numbers assigned to them depends on the type of variables you are using. And the statistical operations on variables require that they are measured quantitatively, using cardinal numbers, using ordinal numbers, or using arbitrarily assigned numbers. So remember, statistics is the science of decision making. By using the tools and procedures of statistics, we make meaningful predictions, meaningful assessments about various phenomena. And for this, we use the tools of statistics, which we will consider in the subsequent classes.